This is a work of fiction. Some characters are inspired from Bollywood classic Koi Mil Gaya and Our Poise class. Other names, characters, places and incidents either are products of the team's imagination or are used fictitiously. Any resemblance to actual events or locales or persons, living or dead, is entirely coincidental. Also, we acknowledge Scam 1992 for using their background music in the movie.
Bye Jadoo. I am gonna miss you. But how are we gonna talk?
Bye bro. I will miss you too. Take this device. It is called a meter. We will use it for communication.
Why is Jadoo not picking my phone? Is he okay? Oh my god. It's Jadoo. Finally he replied. Sir, this is some unusual activity. Our system has captured some signals from space. It must be Jadoo. Good work, keep an eye on this. I want regular updates. Jadoo, do you hear some strange noises in between calls?
Yes, I can hear it too.
I think we are compromised.
Cut the call. We must be fast and save DASA.
How did they reach us? Are they still tracking us? How can we communicate now? Why did Jadoo send these random images? What does he want to tell me? I can't understand what they are, but there must be something that he wants to tell me. Who can help me? Yes, Dr. Kanan from my college can help me. He taught me cryptography during my college days.
Hey Rohit, haven't seen you in long time. How are you?
I am fine, sir. I just wanted some help from you. Yes, sure. What is it? As you know, Jadu has left the Earth. I tried contacting him few days back. But I suspect NSA is onto us. When Jadu realized this, he sent me a set of images. I can't figure out what those are. Let me check them. Do you have those images with you right now? Yes, I have brought my ometer with me. These are the images which he sent me. Do you remember steganography from your college lesson? Oh, yes. I think Jadu, being a pioneer in machine learning, used neural cryptography-based steganography technique. I see that the number of messages exchanged between you equal the number of images he sent you. Maybe he encrypted those messages using RSA and then embedded those messages in the images. You should try to build a similar system. I think this should work. Thank you so much, sir. I expected nothing less from you. Now I must leave. Yes. The decoder is now ready. Another message from Jadu. Let's try to decode these with the decoder I just created. Yes. I got it, Jadu. Any updates? Sorry, sir, I cannot make out anything of these signals now. Maybe they know that we tried to listen to their conversation and now they have changed their communication method.
Hey team, it has been a lot of time since we have been trying to break into Jadu and Rohit's system. Have we got any success, or a college student is too smart for you?
Sir, we have found something interesting.
Sure. Tell me, what is it?
Sir, we observed that Rohit was sending some vector data over the channel.
Oh. Vector data. That sounds interesting. I think he must be sending some feature vectors. Also, sir, the dimension of the data was high. I think they are sharing images over the channel for communication.
What an intelligent move that is. Communicating through images.
Yes, sir, I think we can use this for military too.
Yes, we will see to that, but let's focus on breaking this.
Sir, I think they are using some ML model as they are using vector data.
Yes, that might be it. As Jadu is also sending images, so it must be an encoder-decoder model.
Bang on, sir.
So, sir, how should we go about to get those images?
Great question. Do you guys remember Professor Praveen's lecture on privacy earlier this year?
Yes, sir.
Great. Remember, he talked about privacy attacks on models and discussed about reconstruction attacks.
Yes, sir, we can use those attacks to get images from these feature vectors.
Yes, so let's get going.
Hey, my friend Jadu, how is everything up there? Hello, Rohit. I am good. How are you?
So team, how is the progress?
Good, sir. We successfully implemented the reconstruction attack and have been able to get the images which were being shared.
Yes, sir, we have got images, but we still can't figure out what is being communicated.
Yes, sir, sharing random images looks a bit senseless.
I don't think these are random images. This looks like another layer of encryption to me.
Ah, yes, that might be it, sir.
We didn't think that way.
That's why you are my juniors. You smart guys will learn with time.
Sure, sir, with your
guidance.
Sir, I think if there is a hidden message and they are using an encoder-decoder model, then we can train a decoder to decipher the message.
Already on the way to take my seat in cabin, I see. But won't we have to wait and keep monitoring the channel for getting enough data to train it?
Yes sir, we have to continue monitoring the channel for a good decoder.
Great, be on it then. Can you see to it that we can predict earlier messages also?
Sir. Since we don't have initial images which were shared in communication, we can use membership inference attack to see whether certain images were used by Rohit to train his decoder.
Yes, great thinking there. So get access to it and get it done. Great work again both of you.
Sure sir. We will not disappoint you.
Any success in decoding?
Sir, we tried, but after decoding we are getting some encrypted text.
What kind of encrypted text?
Sir, we think that the text in the image is further encoded with RSA algorithm to provide more security. We can't do anything unless we have the private key.
Then try other means.
But sir, RSA is secure against polynomial time adversaries.
Have you considered side channel attacks?
What is that, sir?
What? Did you even attend Dr. Kannan's class? See, this is what happens when you walk out of the class after attendance and copy your assignments.
Sorry sir.
Ugh, never mind. I want you to read on the side channel attack on RSA. Additionally, look into what device is used by Rohit for communication. I remember some work around side channel attack in RSA. See if you can leverage it.
Okay sir, we will look into it and get back to you.
I want success this time. If you can't find a way to break in, then better retire.
Oh Jadoo, my sweet friend. We are using steganography and on top of that we have RSA encryption. Old device or not, no one can break it. I wonder why are you so insecure all the time? I was the bond of my class, I have 4 8 stars hoodie, no one can break into my system.
Tell me, what is this meeting about? Have you made any progress on Jadu's case?
Yes, sir. She will brief you about the progress made so far.
Good, tell me.
I see that they are using steganography. There were some secret messages hidden in the images that they were sharing. We observed that Jadu encoded his previous chats in a set of images using neural cryptography and sent it. We tried building a similar system, but the messages were encrypted using RSA before embedding them into the images. There is no way we can break this RSA-based encryption directly. It is secure against polynomial time adversaries.
The message are RSA encrypted. There is some research work that suggests RSA encryptions can be attacked through side channel attacks.
Interesting. Have you considered the kind of device that Rohit is using?
Yes sir, we have. A month back one of our detective went to meet Rohit in disguise. Rohit showed him the device that he is using. He calls it ohm meter.
Rohit explained how the device works. Apparently the device was gifted to him by Jadu. The software was coded in a programming language used by aliens on Jadu's planet.
But here's an interesting fact. The device seems to be old. It is from the technology they used at Jadu's planet, but based on our understanding, the processor is similar to ARM Core SC100 completed with a certified DEAL4 Plus arithmetic coprocessor.
This seems interesting. But how are we going to attack?
When we got this information, we started experimenting here at NSA. We got 3 devices similar to Rohit and employed 3 teams. Each team explored a specific attack path, exploiting information extracted either from the electromagnetic emanation or from the power consumption. We then used deep learning models to exploit this information to articulate our attack and guess the messages being shared. The results were remarkable. There is a high potential of deep learning side channel attacks against secure implementations of RSA.
Work. This is great. But how are we going to collect these electromagnetic emanations or power consumption? What about the noise?
For that we want your help sir. Could you ask the electronic department to install a device at his home and modify his phone so that it could transmit the readings from the device? The results here at NSA are very good. We have success 99% of the time. Experts suggest that even with noise, we will have success more than 90% of the time.
Excellent work, scientists. consider your request done. Let's catch him.
Yes, we did it. Why is this network so bad? Do I have to go to my terrace again? Let me try seeing if closing all background apps will help. I've disabled background data usage for all apps, but yet I seem to be using some data. Must just be some standard OS updates, but I feel like I must check this out and learn more. I must be sure to know that NSA are not trying to hack my phone again. But haha, the joke is on them since this is of no use. To be sure, I should talk to Dr. Kanan again. So as you see, Professor, because of what I observed on my phone, I would like to know if NSA have really gotten into my system? And if so, how? Since I have set up the best intruder detection systems on my phone.
Let us take a look at your phone's communication logs, Rohit.
Sure, sir.
This is very interesting. Let us investigate this by running some tests. So we will run some quick tests that traditional intruder detection systems, called IDS for short, use. We will first run a signature-based intrusion detection system, called SIDS for short. This looks at signatures, which is just a fancy word for patterns, of attacks, and tries to match it with signatures of attacks in its database. If it finds a positive, then it will send out an alarm.
Do you think this will work, Professor?
If it does not, we have to try next generation IDS system, but I don't think we have so much time, ha ha ha.
Eraser.
That did not work. This must be because this attack could be a so-called day zero attack, which means that this signature is not already on our database. So let me try an anomaly-based intruder detection system. This works based on detecting any anomalies from expected logging, so this can detect day zero attacks as well. Rohit, for this I will use this new state-of-the-art end-to-end machine learning model I've trained to look through your communication logs of different web apps to find out if there has been any attacks, or data leaks. This is because web apps are often easier targets because of network connectivity and their own vulnerability issues. This model was trained using a semi-supervised approach in which we train on an autoencoder with denoising layers stacked to it with a lower dimensional selection of raw features given as input. This model detects then returns whether there is suspicious behavior or not. Yes. We have found an anomaly. From what I've seen initially, it appears that someone has snuck in a small piece of code which has been uploading perhaps electromagnetic readings from your phone to the internet. This is very interesting indeed.
But how could this happen, sir? I have had a very popular ML-based intrusion detection system on my phone forever now.
And perhaps this is the issue. You see, ML algorithms can be tricked by specific patterns engineered in such a way just to trick a particular model. This is called an adversarial attack.
I don't understand how this works, sir. How can this happen?
Let me explain with a very different example. You know about Tesla's autonomous cars, right? So these cars take sensory input from their cameras and based on the different objects around them, like cars, signals, and signs, they take their decisions and plan their trajectories. But sometimes when a few innocent-looking stickers were taped onto some signs, the model completely misunderstood them. To the naked eye, the signs still looked the same, but model failed catastrophically. The intrusion detection system on your phone too was likely bypassed in this fashion.
Sir. Looks like I was underestimating NSA all this time. Yes, you were? Now you know why they are head of such complex space operations. Those are intelligent learned men after all. Sir, since they have caught on to my system, do you think they will be able to decipher images like my decoder? Obviously, if you are using ML models, they are susceptible to privacy attacks like reconstruction and membership inference. Oh. Sir, I totally overlooked the privacy attacks. Didn't think they could be utilized that way. Ha. Now you know. Sir, so how can I go about prevention from such attacks? Interesting question, Rohit. Though factually speaking there is no well-defined set of rules to prevention. But you can try one or two clever things. What are those, sir? So do your other friends also talk to him? Yes, sir, they all talk to him through my system only, as they haven't configured their systems. So see, what you can do is secret sharing. That is, you can distribute the data and decoding model over different systems. That way it would be secure even if they are onto you. Ah? Great idea, sir. Sure, we can decentralize the system. Wait a minute, Rohit. I am getting an important call. Sure, sir, take it. Okay, I understood. I will be right there. Sorry, Rohit. I have to go now. No problem, sir. But you were telling about one more approach. Ah yes, the strategy is called perturbation, where you basically add noise to your data. Sounds interesting, sir. I will explore it. Thanks a lot. Have a great day. Same to you. Let's meet when I get back. Hello guys. How are you all? I am good, Rohit. What about you? Yes, how are you doing?
How is Jadu?
I am doing just fine, guys. Jadu is good too. We have not talked much recently because I fear the NSA is onto us. Ah, that damn NSA. They won't let friends talk, would they? Heartless machines working there. So guys, I met Professor Kanan yesterday. And he tells me that they have compromised our neural cryptography model and RSA encryption with privacy attacks. So he was telling a new way. I would require your help for that.
Yes, we would be happy to help. We also miss talking to Jadu.
Tell, how can we help? Yes, please tell. So the trick is that we will decentralize my system. That is, the model will be distributed and key will be shared across our systems. That way, even if NSA hacks one system, we will not be compromised. That sounds a nice plan, but there is a problem. My system is too old and it cannot run a decoder, so I don't think I will be of help.
Yes, my old system crashed and my parents are now reluctant to buy me new. So I don't have anything at the moment.
It seems we can't do this. I will have to explore some alternate technique. Okay, bye guys, I will tell when I think of something. Hit bye, take care. Do tell us if we can be of help. Jadu, I miss you so much, friend. I will have to figure out the perturbation. Well, as I read, it seems perturbation is deviation of a system caused by error. How can some error addition help me have a secure communication system? I cannot think of anything.
Rohite, I am in a mess. Yar, help me out, I have no time.
What happened?
I brought home a take-home exam paper, whose solutions I have to submit in 5 minutes. It's 11:50 already.
Okay, but what is the issue? As I know you are taking a very simple elementary algebra course. What can be a possible problem that you have to run to my house so late at this hour?
Yar, I was solving the questions only, when my sister came and spilled over coffee over my exam sheet. Thankfully only a little part of question got just affected, but I seem to find no way to solve the problem by the ruins of the paper I have.
Oh, show me then what is the problem and how much portion of the paper are you left with?
See for yourself, I have sent you the details of the equations on your laptop. We need to find values of x and y satisfying both the equations, but this last characters got faded away by the spill, as you see.
Oh Shampy, this can have so many solutions. How can we solve this? Only if you had some more information.
Ha, and our information teacher hinted that x and y are primes.
Oh, knowing something about the solution surely does help. Let me think.
यार जल्दी, 3 minutes are left यार.
Okay, we can assume those faded last digits are 0 and simply see that in each of the linear equations there's an error of 0 to 9, we just have to solve these set of noisy linear equations.
समझ नहीं आया पर सुन के अच्छा लगा.
Okay, I don't know how to crack this, but let me try all possible combination of errors and find a solution each time to see if I hit prime values or not. Shampy, I am done. The answer is x equals 3 and y equals 5.
I'm also done. It's 10 past 12. My deadline passed. What is use of your Eat Star hoodie? What is use of your bondness? Kya yaar?
Oh, I could not help Shampy, neither can I help myself. Wait, how could I take so long to arrive at a solution for such a basic problem with just a slight change in it? A simple system of linear equations and just putting a small error in each of them makes the problem so hard to solve. Is it really that hard? Error. Error. It's just a noise, exactly as Dr. Kanan had suggested me. With this noise introduced in such a simple problem, we have a hard problem. But is it surely hard enough? How can I use this? It's often the case that a crypto scheme is nothing but a way out that reduces to a hard mathematical problem. Can I build a crypto system out of this? Surely Dr. Kanan can help me answer all of my questions. Hi, ma'am. Is Dr. Kanan inside? I need to talk to him regarding something really important.
Sorry, Rohit, but he has left for Chennai today morning for an emergency that came up.
Oh, when can I expect him back? Can you please tell me?
He may be gone for days, weeks or months maybe, it depends how soon the issue resolves.
Oh ma'am, okay, I shall leave then.
Oh, wait. I forgot to tell you, he said if some student came looking for reference of some problem, hand over him a folder, and to convey that he could not complete his work due to his sudden departure because of the emergency.
Surely it's me. He had been helping me on one of my errands. Now that he is away, I thought I am pretty lost in looking for a path, but it fills me with a hope that he has left something for me.
Take this boy, he surely has faith on you, otherwise he would not have left such an incomplete work behind for anyone to complete his work.
Thanks ma'am, now I shall take leave. How can all this what Dr. Kanan gave me be remotely related to what he had asked me to think on perturbation? This work seems to be in a completely different direction. Here he has discussed various lattice geometry problems and how these problems have an exponential time solution. What are lattices actually? What is the closest vector problem? What is shortest vector problem? I don't understand much regarding this. Let me read upon further on this. Okay, now I somewhat understand lattice. Closest vector problem is actually trying to find a vector in the lattice that is closest to another vector in the lattice, while shortest vector problem is finding a vector in the lattice that is closest to the zero vector in the lattice. The popular solutions to the problem require a reasonable set of orthogonal vectors that span the lattice. Now if I can find such a set, there are algorithms for solving the problem, but finding such a set is what makes these lattice problems hard. An interesting facet of the problem is there doesn't exist even any ML or quantum algorithms that solve the problem in less than exponential time. Fine, I understand all this, but how could possibly any of this relate to my problem at hand? I see, the only common thing that somehow associates the two problems is probably the hardness, so it may be a case that hardness of the problem at my hand. Learning the solutions with error in the specifications might be reduced to these standard lattice geometry problems, and hence the hardness of these lattice problems can guarantee the hardness of my learning with error problem. Oh, let me do some more research on this to get assurance of what I am thinking. Oh, indeed, there exists reduction both quantum and classical from the learning with error problem to these lattice problems. Now what's left is use this smart trick of introducing additional errors and specifications to achieve a solution for secure communication. Soon I hope to find that. There can be no stopping for me to talk to my friend. Oh Jadu, we will connect soon. Okay, I have come so far studying on this. We do have a public encryption system built on this, namely the ReGEF scheme. It seems I can build a scheme for our communication using this, but it still doesn't give me enough confidence if it can be reliable. After all, I cannot compromise with Jadu's security. I cannot let NSA know what I talk to my friend. Ah.
Oye Rohitiye, how are you yaar?
What's up Shampy? Another assignment, another coffee spill, another time you want to mock me for not being able to help you. What?
Arey yaar, this time I have nothing. I just came to meet you to say sorry for being really rude to you last time. I'm sorry, yaar.
Oh Shampy, I realize I should say sorry first. Only if I could solve your problem that day on time, you wouldn't have missed your deadline.
Arey, I am big-hearted. I excused that night right after walking out of your doors.
Also, thank you Shampy. Had you not asked me to solve the problem of system of noisy linear equations, I wouldn't have made any progress in my strive to find a suitable encryption scheme.
Encryption. What is this, yaar?
Oh Shampy, encryption is nothing but simply trying to secure our messages by putting a public cover on our message by keeping some private cover.
Okay, but how did that coffee spill solve your problem?
Oh, how do I make you understand this? Okay, remember your equations. The values of x and y were actually the private cover or private key as we actually call it in cryptography, while the right-hand side which got affected by the coffee spill and we assumed it to be some fixed values having some error was actually the public cover or public key in cryptography.
Lol, when x and y have a role in this movie, the RHS has a role in this movie, why being unfair to the coefficients of the polynomials?
Actually it has got a role. Coefficients are put in the form of a matrix A and it is kept in the cloud, which is actually visible to anyone trying to look at.
Matrix, cloud, encryption, oye baskar.
Ha ha ha, don't bother about this, I will try to move on the path you showed me the way to.
Yeah sure, where your talent could not lead you, my brilliance came to effect.
Ha 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 sure, also once again sorry for not being able to help you that night.
Ah, that's fine, but I just wonder you took so long to even solve that problem even with just one digit getting spoiled. Lol, what would have been the case had 2 to 3 digits of a 5-bit number got spoiled? We would have been still here solving the problem. Ah Rohit, you need to step up your game, okay? I will go now, bye.
Shampy again leaves me puzzled. What would have been the case if we could have the error to be quite large instead of just being small? Wouldn't that have increased the difficulty by infinite bounds? Let me search if we could find a way to have a scope for error to be large enough. Oh no, there seems to be no way right now, as I see it's still an unanswered problem. Something that's called an open problem. It states it this way: people have been looking for solutions of such open problems, no one knows the solution yet. Instead of the error to be just small, it asks for an encryption scheme where the error is proportional to the modulus used in the equations but still bounded enough. How can I fix this? Without fixing this, I cannot start communicating with Jadu right now, I cannot put things at stake. Okay, I have got to fix this. Let this take any amount of time, but I have got to solve the problem. We shall meet Jadu, I don't know when, but we will sure be able to talk again. After putting in so much of efforts, I could build a secure encryption scheme. I could solve the challenge of allowing large enough errors even. But to what use? I sent Jadu the public key with a simple message. The only real error is when we do not learn anything from it. Was Jadu not able to understand that I was referring to a public encryption system based on learning with error? It's been a month since I sent that. But to no use. I haven't got a reply from him so far. How are you, Rohit? It has been a year since you last talked to us, played with us. Guys, please leave. I don't want to talk. Let me be alone as I am. We know not being able to talk to Jadu makes you sad. But here we are. Your other friends who have endlessly tried to comfort you by trying to visit you. But you have always refused.
Yes Rohit, it's enough. You have tried enough whatever you could to be able to talk to Jadu. but you cannot obsess over it. You are a brilliant mind who could be of so much use to this world. You cannot just pull back yourself from the world in your tireless attempt to meet Jadoo and let your rest of the world slip away.
Yes, friends, I do realize over this continuous period of struggle I have distanced away from all my other relationships. With you, my mother and so many more. Was this all futile? No, Rohit. No work is futile. You have learned so much in this period all by your own just to keep up your only hope. No knowledge goes waste. You solved in meantime an open problem, which probably I could not even state perfectly. You just cared for the purpose all this while, without even giving a heed to the actual potential barriers all this while. Whatever you have been able to create surely would be of help to our world where private security of individuals is really at stake. Yes, Rohit. Just imagine what Jadoo would have wanted you to become. To practice, he would have never liked seeing you in such obsessed state trying to contact him. Though he is an alien, he would have surely wanted you to become the best of a human. Oh dear friends. You have made me realize what I was missing on for so long. The true understanding of relationship, where it need not be required for one individual to be in constant touch with the other, but wherever the two be hope for the well-being of the other. Thanks friends for making me realize. Me solving this problem does a lot of wonders which could be beneficial to the world. I would soon start working to see how this can be extended to solving other problems in the field of cryptography and beyond.
You surely would. We are sure of your potential. You will make a difference, but enough of this right now, let's just go visit somewhere outdoors together just like old times.
Yeah, let's move out. I am really excited to see the world again, breaking away from the shackles I had put on myself for so long.
Jadoo.